Scientists can classify reactions based on how the elements get reorganized, such as what we've been discussing: single displacements, double displacements, synthesis reactions. But scientists also classify reactions on how much they transfer energy. When bonds or intermolecular forces are made in a reaction or a physical process, energy gets released. The opposite occurs when bonds or intermolecular forces are broken. Energy is required to do this and gets absorbed from the surrounding environment. In a reaction, there's always an imbalance between the amount of energy required to break the bonds in the reactants and the energy released when forming the bonds in the products. In chemical reactions, there's always bonds that are broken and there's always bonds that are made. Which side has the most energy determines whether or not the reaction is classified as exothermic or endothermic. Exothermic reactions release energy to the surrounding environment and feel hot. This is because the energy released making the bonds in the products is greater than the energy required to break the bonds in the reactants. Therefore, there's extra energy coming out of the chemicals. Some everyday examples are a candle burning or burning fossil fuels like gasoline. A physical change example is ice freezing. When water molecules freeze into a solid, hydrogen bonds get made, holding the water molecules together. Because intermolecular forces are made, energy gets released from the chemicals. This is why we put water in the freezer to make ice. The freezer helps by drawing the heat out of the water molecules. Endothermic reactions need extra energy in order to take place. They absorb it from the surrounding environment, so endothermic reactions feel cold to the touch. This is because the energy required to break the bonds in the reactants is greater than the energy released in making the bonds in the products. There is an energy debt. The extra energy must be taken from the surroundings in order for the reaction to happen. One example would be melting ice. In order to go from a solid state to a liquid state, the water molecules have to break their intermolecular forces. This requires energy. It steals the needed energy from the surroundings, which is you if you're touching the ice. Chemical cold packs that you buy in the drugstore work on the same principle. Two chemicals are separated by a plastic barrier. When you twist and pop the ice pack and mix the chemicals together, they absorb heat from the environment in order to get destroyed and make the products. One way that might help you determine if a reaction is endothermic or exothermic is to look at the roots of the names. The word exo starts with an EX. In Latin, it means to exit. So heat is actually leaving the chemicals. Endo starts with EN. In Latin, it means enter. During endothermic reactions, energy is absorbed or enters into the chemicals. Try out the attached practice questions.